So starting with question number 1, some few questions from SHM. Two particles are performing simple harmonic motion in a straight line about the same equilibrium point. The amplitude and time period for both the particles are same and equal to a and t. At time t is equal to 0, one particle has a displacement a while the other one has a displacement minus a by 2. So let's assume this will be the scenario. This is origin. This particle is, one particle is at here and another particle is at some distance. Another particle is at minus a by 2. Okay, so they are moving towards each other. So let's say this, and they're moving towards each other. So now I need to know the path difference between them. So if we have gone through SHM lecture, this is phase difference 5 by 2. This one will be, as is a by 2, x is equal to a sin theta. So in place of x, you can write a by 2. So sin theta is half. That means theta should be equal to 30 degree. So pi by 6. So this one is pi by 6. So the net path difference between them is pi by 2 plus pi by 6. So that is 2 pi by 3. It's 2 pi by 3. So this 2 pi by 3 path difference they will cover together. So 2 pi by 3 by omega relative should be equal to the time. So what is relative omega? For both of them omega is 2 pi by t. For both of them omega is 2 pi by t, because the time period is same as given in the question. The amplitude and time period is same. So omega relative will be omega plus omega because they are moving towards each other. So 2 omega is 2 pi by t. So it will come 2 pi get cancelled out, t by 6. So in this question number 13, this is a good question from fluid mechanics, and torque concept will come into play. So a uniform rod of length L capable of turning about its end, which is out of water, rest inclined to the vertical, its specific gravity is 5 by 9 and the length immersed in water. So I need to know which forces are acting on it. So let's use some technology. Now this is, let's suppose this is mg, right? And AB buoyant force will act at somewhere. So let's suppose buoyant force is acting from this point. It will be in the middle point of the immersed portion. So about, now you need to balance torque about this point. So this will be mg into, this is L by 2, so this one will be L by 2 sin theta, right? Okay. And if this is x, if this total is x, then it is x by 2. So this total length will be how much? This total length will be L minus x by 2, and this one will be what? Into L minus x by 2. This perpendicular distance will be again sin theta. Okay. If you now this one is rho solid, this one is rho liquid. So rho liquid is 1, rho solid is 5 by 9. If you solve this one, you will get x is equal to L by 3. Option 3 is your answer. Next question is, I will do this one later on. Next, moving on to the another question. So in this question, there are two wire x and y of same length. So there are two graphs given, f versus delta x. This is y. This is x. This is x. But they are of same material as given in the question. They are of same material. Two are x and y same length and same material. So y will be same. So Young's modulus of x and y will be same because of same material. Now the cross section, now for option 3, the cross sectional area, f is equal to k delta x. So this slope gives you the value of k is equal to ay by l, as they are having same length. And for same force, for same force, extension in this one is lesser than is lesser than extension in x. Extension in the y is lesser than extension in x. So you know that extension delta L is equal to what? FL by AY. L and Y are same, so delta L will be proportional to F by A. If F is same, so delta L should be proportional to A. So in this case, delta L is much higher than this one. So area will be lower. So area of x will be, as delta L is more in x, so area of x will be less than area of y. So option 3 is also not correct. And now from here, k is equal to ay by l. You know that f delta x slope gives you k is equal to ay by l. This is equivalent spring constant concept. So if the length are same, y is also same, then you may easily write k will be higher if the area is higher. So area is higher in y, so uh, that's why the value of k in y will be higher than the x. This is a question from viscosity. A cubical block of side A and density D slides over a fixed inclined plane with constant velocity v. So this is a cubical block. Now, if you just draw the free body diagram, so it is given that there is a thin film of viscous fluid of thickness T between it. So then the coefficient of viscosity you need to find out. So let's draw the diagram, free body diagram. So this one is theta, that means mg sin theta will act over here, and one drag force will act in this direction. That drag force is equal to f theta a dv by dy. Del v, the face adjacent to this incline will have a velocity 0, and this face will, and the liquid film adjacent to this block will have velocity v, because the block is also having velocity v. So the liquid film adjacent to this block will have velocity v, and the liquid film adjacent to this wedge is 0, velocity 0, because wedge is fixed. So it v minus 0 dv, and dy is the thickness is how much? T minus 0. So you just equate all those. Eta v by t is equal to mg sin theta. So eta is equal to mg sin theta. uh, Density is given and cubical block side is given. So m you may write d into a cube, g sin theta. Eta area you may write d square into v t. So the answer is coming d a g sin theta t by v. Option 1 is the correct answer. As in the question given that this is moving at constant velocity, so net force will be balanced, because velocity is there but acceleration is 0. This is one more question. The similar concept we have studied in fluid mechanics class lecture. So this is, there is a tank, this height is h given. So you need to apply the acceleration of this vessel in backward direction. The surface is smooth. This is a pretty easy question. You just need to know the velocity of flux. V is equal to 2gh, and force is equal to rho v square, and this force will imparted in backward direction as the fluid is coming in this direction. So m into s will be equal to rho v square. Acceleration is rho a v square. V square is 2gh by m. So this is your answer, option 1. Now moving on to this question 188. This velocity of force rho v square is coming from the formula F is equal to v dm by dt. You will know that v dm by dt, you may write rho into a into L. So rho a is constant, dl by dt is velocity. So you may write rho a v into v, that is rho a v square. And you are assuming this area is much less than this area. Then only this equation is valid. V is equal to rho to gh. A block is submerged in a vessel filled with water by a string attached to the bottom of the vessel. If vessel is moved upward with an acceleration A and the tension in the string, so this is a good question. Uh, See, so in this question, the tension is along this way. The buoyant force will act along this way as it is moving with an acceleration A in upward direction. So pseudo force will act in downward direction. So m into g plus a will be acting in downward direction, okay, and one buoyant force will acting on it. That buoyant force will be fb is equal to rho into v into g. G will be what? G plus a. Okay, so this is the buoyant force. Why g plus a? Because a is upward direction, so pseudo force will be acting in downward direction. So T should be equal to T plus m into g plus a should be equal to rho into v into g plus a. So T is equal to rho v g plus a, you can take common, so rho v minus m, this will be the answer. Let's assume there is no any acceleration in this vessel, no acceleration, so a will be 0. So you may write this is ti. Ti is equal to g, acceleration will be 0, rho v minus m. So if you just take the ratio ti by t, that should be equal to g by g plus a. So t is equal to 1 plus a by g into ti. So you can clearly see that when there is no any acceleration, then the tension is tension will be lesser compared to when there is some acceleration. So the answer will increase, will be the answer. The tension will increase in this case. In this question, a particle performs a agent. Its amplitude is given. Amplitude A is triple at instant when it is at distance 2a by 3. So let's assume this is at 2a by 3. Let's assume the velocity here is v is equal to omega a square minus x square. X will be 2a by 3 square. Now this velocity is doubled, so now the velocity is 3v. So 3 omega a square minus 2a by 3 whole square. Now you need to find out the new amplitude. Let's say new amplitude will be omega, a dash. So you may write 3v. You may write this is omega. Omega will remain same. A dash square minus x is 2a by 3. This you may write v dash. So v dash will be omega a dash square minus x square. So this will be equal to 3 omega this velocity, because at this position what is happening, velocity is increased to 3 times. So now omega will remain same, but this will become faster, because and it will travel a larger distance than the previous one. At previous time the amplitude was a, but whenever you will give an impact such that its velocity is becoming thrice, so the amplitude of the motion will change. So now you may write v is this one, so 3v will be 3 into omega this one. Now the new amplitude will be a dash, so you may write v dash equal to omega a dash square minus x square. So now omega get cancelled out, so a dash square 4 square by 9 is equal to 9 a square minus 4 square by 9, and from there on you can get the answer. A dash is equal to 7 by 3. This is a good question from SHM. There is an oscillator of mass m which is at rest in its equilibrium position. So in this question there is an oscillator of mass m which is at rest, and The equilibrium position is given as this one. A particular mass small m comes from right with speed u, hitting this mass, sticking to it. So initial momentum of this one will be mu. If it get stick with this mass, the momentum will change, and the new momentum will become, let's assume, m plus m into v. So v will be whatever the v we will be getting. So this will be v. Whenever this will return from this position, this will return from this position, its velocity will be v in this direction. While going this in this way, this velocity will be in this direction. But while coming back, this will be in this direction. Okay. Now another mass m is coming in this way. Now what will be the initial momentum? And again it sticks with this one. So now the momentum will be m plus m into v minus mu equal to, as it gets stick, so m plus m into, I am writing, let's suppose this is v1, so I am writing this is v2. So you can clearly see that this one is equal, so this will get cancelled out, v2 will be 0. So whenever the first mass will strike this one, this will gain a velocity. Whenever the second mass will strike this one, then the velocity becomes 0. Whenever the third mass again will strike this one, this will gain a velocity. But while coming back, when the fourth mass is striking this one, so this one will have a velocity 0. So for each even mass, you are getting velocity 0. So this process continues up to 12 times, because there are complete 13 oscillations. So at the 13th time, this will be having a mass m plus 12m and velocity 0, because after each even mass combined with this one, this is having velocity 0, and 13th mass is coming this way. So you may write m plus 12m into 0 plus m into u should be equal to m plus 13m into v. I am assuming this is a v ultimate v, so this is coming mu by m plus 13m. So you are given the value of m, u and all those, so you can clearly find out velocity. So you can clearly write v max is equal to a omega. So this is v max at the equilibrium position. A omega is root over k by m plus m. So value of k is 1, m plus m is 15, v max is 1 by 15. M plus k by m plus m, that is this m plus 13m. So this is 75, this is 1, so a is v max is how much? 1 by 15. So a is how much? Root 75. So this is 5 root 3 by 15. So this is 1 by root 3.